So my name's Mark Bramley. I'm an engineer in the Live Labs group, and I'm going to show you or talk about just-in-time collections, what these are and why you'd want to do them. To give you an overview of what we're going to cover, we're going to look at collection types, simple collections, linked collections, which refers to the question you asked about joining collections together, and then just-in-time collections. I'll show you some examples. One that you might be familiar is the Wikipedia collection that we have available, and then look at some other examples like pulling data out of SQL Server in real time, getting data out of SharePoint. I'll do a recap of the data formats that Andrew covered, going over CXML again, DZZ, and a lot more information about collection image tiles and how those pyramids are built up and how you would create them yourself. And then I'll go through the steps of actually how would you build a just-in-time collection server? What are the requests it needs to respond to? And then think about some scalability aspects. So first, collection types. The sort of basic, simple collection are the things that Andrew talked about that p-author will output. You take some data in, whether it's an Excel file, CSV, and it will generate a CXML file, a DZC file, the DZC image pyramids, and then some DZI tiles under that as well. In general, we recommend that you stick to about 5,000 items, but you could go higher and sort of your mileage may vary. That's what you want to try. So as we showed some dog breeds as an example of this or other collections that we have available. Next is linked collections. So like we discussed before, AMG movie collection. You could be looking at one particular collection that's, say, the top movies. You spot a movie in particular. You click a link in that, and that jumps you into, say, the top comedies or the top family movies. So it's the same type of process that you generate these collections ahead of time, but they're interlinked in some way. A just-in-time collection is one where you have an enormous data source or a rapidly changing data source, and you want to view particular slices of it at once. For example, the Wikipedia just-in-time collection that we released has 2.5 million items in it at the core. We took the 23 gigabyte data dump from Wikipedia, parsed through it, loaded it into a database, and pre-generated some imagery, some cards for each of those items. But at request time, it does a query against that database, generates the CXML in real time, generates those DZC collection pyramids in real time, and then once you zoom into the bottom, just serves up the base image. We didn't generate the deep zoom images, the DZIs ahead of time. That's probably not an approach you want to take, and I'll mention why later. So why would you use a just-in-time collection or these other types of collections? Well, we've gone through some of the reasons of the size limitations. Of simple, you probably don't want to go more than 5,000. Linked, you can go potentially unbounded, but maintaining all these links just gets more complex as you want to do more things. And with a just-in-time collection, your size is unbounded. How big is your data source, really? Looking at how difficult it is to actually host these things, the simple collections, well, they're just files on a file server. That's one of the beauties of Pivot, is that once you've built these things, you don't need any special server software to host these simple collections, or even linked collections. They're just files on a web server referenced by URLs. So hosting them is fairly straightforward. To host a just-in-time collection server, well, it's server software, and you need a back-end database, or you're making calls out to web services. You need to think about scalability issues and so on. Thinking about how long does it take you to generate the collection, Andrew talked about using the p-author tools to generate static collections, probably half an hour or so for larger collections like the Winter Olympians. The linked collection sort of expands that even further. How many sub-collections are you wanting to building? Multiply that cost. For a just-in-time collection server, it's minimal. At request time, the request is made to the database, generates those images, and there it is. So you get instant gratification, really. So looking at the benefits across all of these areas, the simple collections are pretty easy to do, but you have a size limitation. Linked collections are a great way to make hierarchical collections. For example, if you have, say, an organization and you have different divisions with different employees in different divisions, or product categories with products within them, this is a good way with a few levels of hierarchy to expose those collections. And then for just-in-time collections, these are the best for if you have a very large data source, data that's updating frequently, or if you want to, inside the enterprise, pass on enterprise permissions. Perhaps some group of people are allowed to look at one data source but not another. And if you're building simple collections, you don't want to have to recreate those types of permission states. So now we'll go through some examples of just-in-time collections. Wikipedia is one that I hope you've seen already. We'll look at building something from SQL Server, Twitter, and then also OData, the Open Data Protocol, is a format built on top of the Atom specification that allows people to publish data in a standard way that many clients can understand and consume. And people are starting to publish their data on the web in this format. Netflix, SharePoint 2010 uses this format, SQL Azure, Blobs in Azure, the Open Data Initiative or Open Government Data Initiative as well, is publishing things in this format. So let's just look at some of these and what they might look like. So you may have seen the Wikipedia collection inside Pivot. The file formats are exactly the same, whether you use the Pivot desktop application or the Silverlight Pivot Viewer, same types of data. So this is actually, and forgive my UI, I'm not a graphic designer, but the page design is there, so I have links to copy and paste. This is a previous version of the PivotViewer Control running in a Silverlight application. Andrew and Ralph will show you the latest later on this afternoon. But you can see that this is the Wikipedia collection that you might have looked at before, and you get all those, or the ability to navigate around and look at it in terms of different views. But think about the potential of this. Usually the way people get to Wikipedia is you go to a web search engine, you end up with some links to Wikipedia, you jump into a particular article. If you want to look around, you have to go navigate the links. This experience could be a lot more interesting, as if you find an article that you're interested in and you want to read about, but then you can just click this link, and this in real time will go and query the database, generate a new collection that you're looking at, sort of pivoted on that particular topic. And you can swim through this collection, generating new views over and over and over. Something else that I have is a SQL Server database running on this laptop, and the SQL Server team provides some sample databases. One of them is called AdventureWorks, which is a fictitious company that manufactures bicycle parts. And so if we actually look in the SQL Server tables, they have things about the human resources, the people in the company, the products they actually sell, sales orders, purchasing orders. And in here is a table with actually the list of products. So to actually go and query this in SQL Server, you have things like the name of the parts and the product number and the color. And typically if somebody in a company was going to build an application on top of this, they'd use an ASP.NET data grid or some other form to actually display this data. Now, fairly easily within Pivot, it took me about 30 minutes to write the code on top of the sample code that you all have in your USB keys to write an adapter that calls into this SQL database and shows it as a Pivot collection inside the Silverlight viewer. So you can, and again, forgive my graphic design skills, they're not very good, but you can see that I've pulled in the names, and these are all drawn in real time. So we made the request, we actually drew out all these images at request time. The names of these different parts, you can see that I've added some facets so that I can filter or show a graph based on the list price of the items, and you can look at what the most expensive things are, for example. And again, this gives you a very quick and easy way to navigate a data set in a visual way where you can start to see trends that you couldn't see from a purely tabular source. So think about your data sets that you have, what you have in databases, and how you might expose some of those things. I have a collection here for Twitter, but there's a problem with Twitter. Let's see if it exists. They rate limit calls to their API, and calls from here go through Microsoft proxy servers. Lots of people at Microsoft are writing apps that call Twitter. So unfortunately, I'm not getting data from them right now. But if I copy this link, and there popped up, you just saw another thing that I built off the sample collections. I think I can say URL equals, and if I open this one in a new tab and copy the shortcut, equals. Now this hopefully will look familiar to a couple of people in the audience. Twitter or Microsoft customer support have a Twitter username, Microsoft Helps, where people can tweet their support requests. And so this is a collection of the replies that have come from the Microsoft Helps account. And so very easily, because in a Twitter feed you have things like a topic or even users, you can look at who are these people who are being replied to, or what are the top products that are getting support requests. Unfortunately, in the static collection I grabbed, it's just Windows 7, but usually you'd see things like Office and Exchange. And again, you can turn this into a grid view, and you can go look at what are the top support requests, or even when was the published time of these particular tweets, and so what's the trend over time, for example. And then if you actually want to see the detail of what these things are about, you can dig in and see all the information right there. Looking at OData, I mentioned Netflix. So if we just look at the raw data, this is the Atom Pub document that Netflix publishes about the collections that they expose. The word collection here is overloaded. Atom uses that as well to refer to Atom feeds. So you can see that they expose various collections in terms of movie titles and what genres they are. And then also, if we go look at the raw XML for some titles, i.e. shows it because it's a feed and asks me whether I want to subscribe to it, you can see in here things like the entry, and here are various properties like the runtime of this movie or its average rating and what year it released in. So this is the OData, the Open Data Protocol spec. So I've written a small adapter that just takes this, pulls up the feed, and in real time will go query that. So if we just pull in this catalog, and load it. So the Silverlight pivot viewer on this page went and queried the local running web server. That made a query out to the Netflix API, pulled that data in, converted it into items, drew tiles for these in real time. And then similar in a way that you might link collections, you can actually open the titles collection. And so then this will jump off, make another set of several web service requests to go pull in the titles data. So these are various movies, and you can quickly and easily see, again, trends within this collection. Perhaps you want to sort by runtime and pick, or look over runtime here and just filter it down to the shorter movies, for example. But again, a data set that was, because many people are starting to publish their data in this format quickly and easily, I can go point this thing at anything. You see that it just points the source to this URL, and we can grab other things, which includes SharePoint. So SharePoint 2010 have started exposing the data about, or data about the things that are living in a SharePoint server in this OData format. So if we grab this last URL, I have a SharePoint server that I set up recently. And so if we can just go load the overall metadata about it, you can see things like they expose the announcements. So if we open that collection, here are the data from SharePoint announcements. Let me reload the page. And then we can look at things like shared documents within my SharePoint server. Here are just some samples that I dropped in there. The Office team, you can imagine, have lots and lots of requirement documents. So what they've done is actually built a collection, a pivot collection, based on their SharePoint requirements spec document library, so that they can go and quickly and easily pivot on which things are up to date, which are in draft form, who authored which things, and quickly navigate around the set and display it in an alternative, some might say richer way than you'd get from just looking at things in a SharePoint list. So now let me switch back to the slides. So now I'm going to go through a recap of some of the data formats that Andrew mentioned before. So looking at the collection XML, the CXML again, starting line by line, we have the XML description at the top, a collection element, which has the name of a collection, a schema version, always 1 for this version of Pivot, and then the namespace that this XML document belongs to. At the top, a set of categories. So in this collection, we expose a name, a nickname that has a type of string. Somebody's weight, again, this is of type number, and you can specify a custom format string so that when the pivot viewer displays this, it formats it in this way. So the number would come out as the value pounds. A birthday category that's of a date type. And at the bottom here, these are hyperlinks. So we've given the name C:, so that's what shows up in the info pane on the right-hand view. And I've said, is filter visible equals false, so that it doesn't show up in the filter pane on the left. It's purely for hyperlinks that you want to show in the right. Going into the next section of the CXML, at the top is the items tag and with the image base that refers to the DZC, the deep zoom collection file that describes the images. We have an item of ID 0. The name of this item is Alice. That gets displayed within the info pane. And the image number #0 that refers to the image data in the deep zoom collection file. Here we have an href, a URL to actually the data behind that person if you double click on the item so that you can launch off to that page, a short description, and then the list of the facets. You can see here that we have specified the nickname as Al, the weight as number 123, a birthday, and under the C facet, we've specified multiple items. In Pivot, all facets are multi-value properties. You can set any number of items or any number of values on a particular facet. So here, we've shown ways that you might link into the same collection. Clicking on one of these links will launch into the Wonder CXML collection and then say, with passing the server a parameter of friends equals Alice or foes equal Alice. So that the server can then take that value and give you a new collection based on that. So this really gets into the nuts and bolts of how Pivot provides its rapid image performance. Andrew mentioned this a bit, that we start with, here I'm beginning at level 3. So this set of pyramid tiles typically go from a level 0 to a level 8. We start with super, super small thumbnails, all packed onto one 256 by 256 image tile, and you can see that right at the top. To move to the next level, imagine cutting that into 4 and then expanding it. It actually goes from the bottom up, but in the order that Pivot loads it, this is how it goes from the top down to the bottom. And so you can see that top quarter becomes the first tile of level 4. The one on the right, top right, becomes the next tile in level 4. Because the bottom 2 are empty, they don't exist. They don't need to exist. They have no item data in. And then similarly, you can see the same splitting level 4. We chop each tile into 4 and then move down into level 5. And again, on the right-hand side, it's only the top corner that contains image data, so there's no need to have the next set. And this is how the folders and the files are actually laid out if you had them on disk or on a web server, or the same requests that for a just-in-time collection server it needs to respond to. So there's a folder number that contains the level, and then an x_y parameter of which tile number it is. So at level 3, it's just a 0,0, x, y of 0. At level 4, we have a 0, 0 and a 1,0 image tile. And then down at level 5, we expand this to further coordinates. We go out on the right to 2,0 and then down to 0, x0, y1, and y11. Moving on to the next set of tiles as an example, just so you can sort of see the detail. I've missed out everything except for the 0, 0 tile. You can see that it expands down, down, so you get 16 images per tile, 4 images per tile, all the way down to 1 image per tile.
So is the image element in the CXML referring to the level, the #0 in there?
The #0 refers to a line in the DZC file. We'll get to that just right now. So this is a description of the DZC file, the Deep Zoom Collection Manifest. It also has a collection element at the root, a different meaning of collection in this case. The tiles can be of two formats working with the Silverlight deep zoom technology, JPEG or PNG. You can specify the maximum level of tiles. So the examples that I showed went from 0 to 8. This allows you 65,000 images in your collection. If you want greater than that, you can sort of up the number. But this is a reasonably good value. Even if you have less than that number of images, it allows Pivot to display you something right away because it can go grab that level 0 tile, just 256 by 256 pixels, and give you a 1 pixel image or 1 pixel image per item. And then at the same time, it requests the following levels to give you something very quickly. Tile size here at 256 is the dimension of the tile. Generally 256. It must be a power of 2. In the Wikipedia collection, we used 512 just to get better resolution of the text. But again, it's a trade-off that you need to make between how large you want your data to be and how quickly you want it to load. N is a Morton number. We'll get to that on the next slide. And then source in particular refers to the DZI, the deep zoom image, if you have them beneath that underlies these collections. If you leave this empty, then it'll just display the images at the maximum level of the collection, so a 256 by 256 maximum size image in this example. And here also it specifies the size of the underlying image so that Pivot knows how to display them in what aspect ratio and in relative sizes and which pixels to pull off that tile. So that went through some of those formats, and then let's look at what you'd actually have to take to build a server that responds to the requests that Pivot sends you. So for a just-in-time collection server, it needs to listen to something.cxml, usually the collection name, and hand something back for that. Something.dzc, and hand back the DZC, the deep zoom data for that. And something that looks like the format that we saw on top of those image tiles, where it's a name underscore files slash a level number, and then x underscore y, followed by JPEG or PNG, whatever format, image format you specified in the DZC file. So if you were going to do this in ASP.NET, you'd create an implementation of iHTTP handler for each of these types of things and register them in your web config as follows. And you can see that under each of these handlers, it adds one that handles get request for CXML and sends it to this particular class in this particular assembly, the CXML handler in the Pivot server assembly. Similarly for DZC, and then lastly for image tile request, and you can see the path is again of the format star underscore files slash star slash star dot star star underscore star rather dot JPEG. So any request that the server gets of these types of that follow these patterns in the URL, it'll send to these particular handlers. As a note, if you're writing an ASP.NET application, usually you might think of ASPX handlers as things that respond to page requests. ASPX handlers have a fair amount of overhead to deal with page requests and setting up session state and things like that. So it's preferable for performance to, if you don't need all that stuff, to use a generic handler or a specific implementation of an HTTP handler. Just a note at the bottom, it can be fairly complicated trying to watch the pattern of requests in your server. Pivot will send to your server a CXML request, a DZC request, possibly another CXML request if you've broken things in two, and we'll touch on that, why you do that later, and then several image tiles and perhaps DZI requests later. So there's a tool called Fiddler, and you can download it for free at fiddler2.com that lets you look at the requests that are coming into your server and actually be able to inspect the contents of those requests and the responses. And a tip is that if you're using this tool, be sure to call your web server using the local server name itself, not localhost. Otherwise, you won't see anything in Fiddler. And we'll look at that. I'll give you an example of doing that this afternoon when we actually walk through the code of building a collection. So how would you respond to these things? First, you get a request for a CXML file. Well, usually you want to do something for a just-in-time collection, like query a database or go call another web service to get some values, such as like we did with Twitter or calling the AdventureWorks database. Create the XML response. We look through the CXML file, and you basically fill out all those values in XML. The collection element, which has the name and the icon attributes, your facet categories that you want to set, and then the name and the types of all of those. The items containing the image base element, which refers to your DZC, deep zoom file, and then all the items within the collection, which have their ID, their image reference to the DZC, the name of the item, href, description here if you want to include it, and plus all the facet values that apply to that item. Now think about what Pivot does after it gets the CXML back. It goes and looks through it, it picks up the items element and reads the image base tag off it, finds that DZC name, and goes and makes a request for it. So for your server to do the right thing, it needs usually a unique value to hand back to that. If you have rapidly changing data, somebody who requests a CXML file 10 seconds after you will want a different DZC, not the same thing. Otherwise, your images and your collection data will be out of sync. So usually it's best to use generated GUID, for example, to do this. Or if you have data that you know isn't changing very often, like the Wikipedia collection, for example, we took the URL of the CXML request, so the wikipedia.cxml question mark and all the query parameters, hashed it into a string and put that here. So the value of doing that was that we use a content delivery network. Companies that are examples of this are Akamai or Limelight, who provide servers on the internet that cache your content so that your web servers don't get hit as often. The requests come through those servers into yours. And so to avoid our servers getting hit for every DZC request, we created something that we knew would stay static within their servers so that when they had that value and it was still in their cache, that they just handed it back again. Lastly, for reference, you can find the Pivot schema description and a download of the XSD file on the Get Pivot website under developer-info XML-schema. So that was the CXML request. You've handed back the CXML containing the list of your items. Then comes the DZC request. Now remember when we looked at that, it just had a brief set of information that was mostly the size of the image. So that's what you need to grab and send back. Now think about, you made, at CXML request time, you queried a database. You got several results from that database. You don't want to have to make that same database request again. So you usually put that data at CXML request time into a server-side cache so that when the DZC comes along, you can load that collection information from the cache and quickly build this DZC. If you're drawing your images yourself, like I showed for the examples before with SQL Server or Twitter, I knew all those items were just 256 by 256 pixels. Those were the items, that was the size that I was going to draw them at. To make it even faster, I could just hand back those values directly. So once you have that information, create the DZC XML response. It has that collection tag with the image format, number of levels, size of the tile, next item ID, and then all the items with their numbers and the size of the items. And I think I mentioned before that if you have deep zoom images underlying your collection, you can hand back the DZI path in the source. But if you don't want to do that, if the maximum resolution in the DZC in the collection image tiles is sufficient, just leave it blank. And again, at the bottom, there's a great web article that has the deep zoom format and download for the XSD. And then lastly, you'll get multiple image tile requests. So these requests come in asking for those collection image tiles at different levels for different X and Y values. And so when one of these requests come in, you want to either pull the images if you have images behind your data, or if you don't have any image data behind it and you just want to draw it based on data that you have, like the name and the description, for example, like I did in some of those examples, you'll just draw those into those bitmaps at this time. The way that the images are laid out on a particular tile is using a Morton or Z pattern layout, and you'll see why it's called Z in a minute, or maybe you can see it right now. If you have one image per tile, that's the not very interesting case. It just fills the tile. The next is to double the number of images along each axis. So on the left, we have 2 images in the X dimension, 2 images in the Y, and so you lay those four images out as 0, 1, 2, 3 in this Z pattern order. And then when we double the number of images along the X and along the Y to the next tile, where we have 4 along each axis, 16 altogether, you can see it follows the same Z-type pattern for every sub-quarter. So 0 to 3 follows that Z pattern, 4 to 7 follows that Z pattern, 8 to 11, and 12 to 15, and so on. And this is a fractal layout, a self-similar layout, because at every resolution it follows the same pattern. So look at how those quarters are laid out. It's the same Z pattern higher up. So an interesting way of how you actually generate those things is that a Morton number is the y and the x coordinates in binary interleaved. And so if, let's drop down to the example where x is 0001 in binary, you can see the blue and the orange values correspond to the x and the y coordinates, and the Morton number is 1 interleaved. Moving down a row where the Morton in binary is 1, 0, that corresponds to a y value of 1, but x of 0. Further down, where the Morton in binary ends in 1, 1, so 3 decimal, the x is 1 and the y is 1. For the next level, Morton 1, 0, 0, in binary 4, x is 1, 0, so 2, and y is 0. So thinking about 4, where our value that had coordinate 4 is, it's at x 2, y 0. And you just follow that pattern, you can basically keep going, it's the same. Just thinking about the number of items that you have to draw on a particular tile, and this is the common example of having a maximum level of 8, so actually 9 levels. A request for level 0, there are potentially 65,000 images. They're all 1 pixel by 1 pixel size, so you don't really want to have to make a request to a database or even draw that number of images onto a tile at this particular time. So there are various strategies that you can take to sort of minimize the load. Pivot uses this technique so that the user doesn't have to wait, but what value do they really get out of seeing a 1 pixel by 1 pixel image? You might detect the color, and that's about it, or the intensity. And similarly, as you move down the pyramid, but notice that at lower levels, the images are larger, but you have fewer of them per tile. So an interesting strategy is to say, at level 4 and above, maybe, that I'll just put a color on for each item. And then below that, I can actually draw the full resolution image. Or, well, the image shrunk down to the appropriate size to fit on the tile. So this means that you don't need to load an image off disk or draw something complicated at a lower level, for example. You're just drawing a flat color onto that. One of our engineers used this technique for a product studio database that we have. So we have a bug tracking database called Product Studio for those folks not at Microsoft. And so he colored the problematic areas red, the things that were okay green. And so at a high level, you can look at a graph view within Pivot and instantly see those trends. And then you spot something red that you want to dig into, you click on that, you zoom in, the request comes into the Pivot server, and at a lower level, it sort of fills out the full resolution and draws out the title and the description and who owns it and so on. A good solution. So now let's think about some scalability considerations. We just talked through the mechanics of what your server needs to respond to, but you can do it a smart way, or you can do it in a way that you need to spend a lot of money on a lot of servers. So something obvious is output caching. So you think about requests will come in to your server for CXML files, DZC files. If the user hits refresh, you don't have to have your server do work to re-query your database or regenerate those images. So a simple strategy is to cache output values and just hand the same thing back again. Depending on your data set, you can choose how often to expire those things. It might be every 15 seconds that something falls out of the cache, or maybe 10 minutes or even longer, perhaps. Depends on your case. If you're making requests to a database or web service, cache those values. You saw Twitter, I couldn't access it. If I had it cached from earlier, it would have been there and ready to go. So again, this sort of helps you protect against service outages from other sources as well. Look at caching your source images. If you have to load these things off disk or make a network request to have them, cache them in memory, or preferably in memory on disk if you have to, if you're caching an awful lot of them. And you might think about caching the original source image that you generated plus smaller versions. Think about how those requests for the DZC come down levels. you might want to pre-shrink, say, one level for level 4, so that when you generate level 4 and higher, you can just use that smaller version. Less data needs to be used when you're sort of subsampling those images. Optimize a database schema for the way that your data will be queried. You might have a large database that's read-write, and you might want to make a custom read-only database that's denormalized, for example, so that it's fast to hand back these requests. When your web server is doing things like making a database request, calling an external service, loading a file from disk, these things are places where the CPU has to wait for that response to come back. But it doesn't have to wait. .NET has asynchronous patterns where you can say, I want to wait and be notified when this event has happened, when it's loaded. And so you can hand back the thread that your query is operating on back to the web server thread pool. Web servers typically have a pool of threads that they use to service requests. If you're tying them up, waiting for database requests or for other things, then you're just going to reduce the number of people that can use your service and ultimately lower its capacity. Make sure you do this right, though. There are easy ways just to try and think you're doing the right thing, but you're just using another thread and tying up CPU time. I mentioned earlier that it's possible to have a secondary CXML file. This is an optimization. If you have a lot of data in the description elements, that can really make your CXML file or initial CXML response very, very large and slow down the time that it takes to get your initial view. So what you can do is in the collection element, in your first CXML, specify a secondary CXML file that just contains all the description data. So Pivot can load the first one, get all the facet values, the number of items, show you something, and then in the background load the description data so that once you zoom into an item and the information pane shows up, it has the description data ready to go. Or if you want to do the word wheel full text search across description data, it's ready then, but you don't need those things immediately. Balance image file size and image quality. Looking at those Wikipedia image tiles, we made them 512 by 512 pixels so that we could, the text looked a lot better there than 256 by 256 where it was fairly jaggy. Although initially we generated them full JPEG quality, and honestly, if you drop the JPEG quality to 90, 85, we shrank the size per image from 80 kilobytes to 40 kilobytes, a lot less data, and it still looked good enough. So this is something to think about. I already mentioned handling different image level requests differently, like handing back just a color at the smaller thumbnails and then filling out details at greater depth. If you do want to use DZIs, deep zoom images, so that once you get into an image, you can zoom way in and see a lot of detail, you usually want to pre-create them. I mean, think about usually where they come from. Let's say you have a 10 megapixel image. At runtime, you don't want your server have to be loading a 10 megapixel image and then try to chop it up. So build that ahead of time, but it's a static image. A reason where you might want to generate them on the fly is if you have an image assembled from other parts. So thinking about Matt's example before, where he had a coffee store and then somebody's photo in the bottom and then a little arrow showing what the sales trend was. Since those are small elements in a particular corner of the item, you could have the overall thing generated and then just draw those sort of rapidly changing items at runtime, for example. Now, when you're hosting a server, the way to scale is to add more servers. So how might you do this? The way it usually works is that you have a load balancer at the front that takes requests from the internet and then distributes them amongst various servers that are running the same software. One naive approach might be to say, well, a particular client session is coming in and we know that they're going to be serving the same CXML and the same set of images, so let me tie that to just one server. So only that server has to know and store that stuff. This is called client-server affinity. You're tying a client to a particular server. In general, I'd recommend you steer away from it, though, because imagine what happens if you get a number of clients all tied to one particular server. They get a pretty lousy experience where other people on different servers get a good experience. And then what if that server dies? Let's say its fan goes out or something. all those people lose their sessions. Whereas everything's distributed nicely across all the servers in your farm, you get a much better experience. Think about separating the database from the image file storage. You want your database request to come back fast, and so that you can hand back the CXML as fast as possible. If you have images tied up in your database as well, then it's going to slow everything down. So putting those across different systems usually helps. It can be helpful, though, to put the sizes of your image in the database so that you've got that stuff ready to go when you want to send back the DZC response that just has the size of those images. Image tile generation is a naturally parallel process. I mean, we split those tiles into 4 and into 4 again and into 4 again. So you can spread that across processors on a server or across different servers. And so you can use a map-reduce type approach where you split the job up into multiple chunks of work, the map those jobs out to different servers, and then reduce it back into one server that tiles all the final results together. So rather than, say, a particular server that handled the request having to draw and shrink 256 images onto a tile, it can just pull in the work that other servers have done and just stitch 4 of those things together. And lastly, think about using a centralized cache, one particular server that serves as a cache, or a distributed cache, i.e. When something gets put into a cache by one server, it propagates it using a queue mechanism to all the other servers. For the metadata that you need to generate the DCC and image tiles, the reason for this would be a request comes in on one server to one server for a CXML. You know a request is going to come into the load balancer for a DZC. If you're load balancing and not using client-server affinity, it could come into any server. So that server wants to be able to retrieve the data that you grabbed without having to do the expense of a database query or a web service query, but you could pull it out of a distributed cache or out of a server that's acting as a cache. Although something to be aware of is image data can get rather large. Something that we had noticed when trying some of these techniques was that you can flood your internal network in your server farm just because of pumping images backwards and forwards to propagate these caches. So again, it's sort of application dependent. Don't apply these techniques as generalities. Look at each of them for your scenario and which ones might apply best. So just to summarize, we looked at different types of collections, why you might want to use a simple or a linked or a just-in-time collection server. Showed you some examples of reasons to do this: Wikipedia, SQL Server, SharePoint, Twitter perhaps, and the OData formats. Dug a bit further into CXML and DZC and the way collection tiles are laid out. And then the type of requests that you need to respond to build a just-in-time collection server, and how you actually respond to those requests for CXMLs, DZCs, image tiles. And lastly, looked at things to do with scalability, some options to consider. So the question is, can you just point the Silverlight PivotViewer at an OData feed to get a just-in-time collection? No, you can't. Right, no, you can't today. You need a piece of server software in between that knows how to translate between the OData format into the CXML and Pivot formats. So the question is, I had mentioned at the different levels of the image pyramid that you could, say, use color at the top levels and then a richer image at the bottom. The question was more about, what about specifying different images for every level? And I sort of hinted at one aspect that you could do about sort of pre-shrinking an image to have a smaller version, but yes, they could be different images altogether. I mean, again, be careful about if you have a different image at every level and you need to load those off disk somewhere, just the performance hit of doing that, possibly. But it's certainly, try it out, see what the experience is and whether you like it or not. It can be confusing to somebody viewing the collection to have things changing under them all the time. So just for everybody else, Matt made the point of, for BI collections, for example, you might just put some extra data like a graph or numbers on the maximum resolution version. I mean, also that means that you only have to make the query to go get that data, potentially, when you want to display that 1 or, say, 4 items on screen, so it's a lot less expensive. So the question is, why didn't we make the just-in-time server available? Releasing server software from Microsoft, it has to be rock solid. And so the amount of development and testing that we need to release that as a package software would be rather large given the size of the team that we have. So our approach will be more to release it as sample code that gives you the basic foundations. I mean, there'll be things that you need to do more in terms of error handling or scalability or reliability, but it gives you the basis to be able to play with it and move from there. Possibly in the future, though. The question is, will that code be available as open source later on? That's very likely the direction we'll take. As Andrew mentioned, the p-author toolset, he's releasing that for open source. We expect that this stuff will build into that toolset as well, yes. So the question is, did we implement the web server farm ourselves, and if so, to what depth? So yes, we did. A lot of those items that I mentioned were things that we learned and implemented, or things that we learned and wish we could have implemented if we had time. There are things that we're sort of thinking about the next revision, or publishing these servers on Windows Azure, for example, that we'd actually go and implement those techniques. You know, Windows Azure, for example, makes it very easy to do a distributed cache with their App Fabric tool set that is there.